we say x is the independent variable and y is the dependent variable because y depends on the value that you choose for x. Whatever x is, y is going to change. Okay, now when we see this notation here, function notation, this is read as the function. Well, it is the function of x, so it's read as f of x. Down here it's g of x. You can use h of x, any letter you want, but it's talking about a function, and it's saying the function of x. So what we're really talking about here, y is the function of x. So down here where we have f of x is equal to x squared minus 2, f of x meaning y, because y is a function of x. So if we have f of x is equal to x squared minus 2, now you notice we don't even have a y written here, but the f of x is talking about what our y value will be. So f of x, for that x, we're going to plug in whatever number it tells us. So it says f of x is equal to x squared minus 2. What is f of 2? That means plug in 2 for the x, right? So f of 2 will be equal to 2 squared minus 2. Well, 2 squared is 4 minus 2, so f of 2 is equal to 2. If you're going to find f of 0, then you'll just plug in the 0 for the x. Everywhere there's an x. And 0 squared is 0, and 0 minus 2 is negative 2. So f of 0 is equal to negative 2, which means y is equal to negative 2. Okay, now let's look at these. And those are very simple to do, right? Okay, now we'll look at this next thing that says find the domain and write it in interval notation. Well, this is also very easy to do. If we look at this first one, a, okay, h of x is equal to 6x plus 3. Well, that's y is equal to 6x plus 3. Essentially, that's just a linear equation. And so we know with a regular old linear equation, just with the exception of that x equals something, but all the other linear equations are all functions, and x can be equal to absolutely anything. If we chose 0, 6 times 0 is 0 plus 3. 0 plus 3 is 3. So we're fine there. So the domain is going to be, remember, writing in interval notation, the negative infinity, because it's all real numbers, right? So that's all of the real numbers from negative infinity through positive infinity. So there we have our interval notation. That's everything, and if you think about it on the number line, here's 0, here's 3, negative 3. Okay, so it would just be all of the real numbers like this. So the smallest thing it could be is the negative infinity, and the biggest thing it could be is the positive infinity. Okay, now we look at the next one, though. It's a little different because what we have is f of x is equal to 1 over x squared. Now, x is in the divisor, and when you think about this, what cannot we divide by? We can't divide by 0 because it would be undefined, right? So x can't be, and 0 squared is going to give you 0. So the only thing it can't be, we can say x cannot be equal to 0. Okay, when we think about that, then we say, okay, so if we're going to graph that on our number line, well, here's 0, and we say, okay, it can't be equal to 0. It can go right up to that 0, but it can't be equal to 0. So all of the negative numbers except 0, right? And all of the positive numbers except 0. That's how we graph it on the number line. And then to write our interval notation, we can see from how we graphed it on the number line, the smallest thing it can be is negative infinity, okay? And then it can go right up to 0, but not include 0. So we'll put 0 with the parenthesis, right? Okay, and then this is something new we haven't done before. We're going to put this this big letter U looking thing, which means union. So it's going to be the union of, okay, the smallest thing it can be is 0. The biggest thing it can be is positive infinity. And there we have it. This way, when we write the union, it's showing, when we write here with the parenthesis, that means we didn't put a bracket, because bracket would mean, yes, it can be equal to 0. Well, it can't. And so we use the parenthesis there on both of these because it can't be equal to 0, and the union of those two is actually the way we graph, or the way we write our interval notation. It shows that 0 is not included. Okay, and we look at this one, well, 2 minus 5, f of x is equal to 2 minus 5 over x minus 3. Well, 2 minus 5 is negative 3, but x minus 3, and we're looking at that and we're thinking, well, x can't be equal to 0 because it's in the divisor, and so we're looking at, okay, well, I guess first we would think about what can't x be equal to. X, oh, I goofed there a little bit. On the bottom, whatever's on the bottom can't be equal to 0. Therefore, x, what value of x would give you 0? Well, that would be 3. So x cannot be equal to 3 because that would give us 0, and we can't divide by 0. Okay, so here we have our little number line, okay, and 1, 2, 3, here's our 3. X cannot be equal to 3, so everything less than 3 it can be equal to. Everything greater than 3 it can be equal to. It just can't be equal to that 3. So when we write our interval notation, we can say, okay, for this first part, the smallest thing it can be is negative infinity. The biggest thing it can be, it can go all the way up to 3 but not include 3, so we put the parenthesis in. And then we're going to put our union in and say, okay, the smallest thing it can be here is 3, and the biggest thing it can be is the positive infinity. So putting this union in and the parenthesis, we can see the only thing it can't be is 3. And there's our interval notation.